Dear students, in this session we are going to learn about functions in C++, parameters and different types of parameter values, function overloading, then the uses of functions such as cohesion, coupling, data encapsulation, data hiding, etc. Also, we are discussing some sample programs in this video. First, functions as modularization tool. Modularization means splitting large programs into small modules. So in modular programming, functions are used for modularization. Breaking a program into small modules helps the programmer to develop large projects by different programmers. Usually, in software industry, a large project is divided into many programmers, and each programmer is assigned a task of a module, and finally all these modules are linked together to complete the project. This is the advantage of modularization. Each module is called a function. A set of functions are designed by a particular programmer. Another set of functions are designed by another programmer, and finally it is compiled all together. Then function is a collection of C++ statements to achieve a specific goal. Just like a program, a function is also a collection of C++ statements to achieve a specific goal. Data can be exchanged between functions by using parameters and return values. That is the advantage of a function. We can exchange data in between functions, from main program to one function, or from one function to another function. In between functions, we can exchange data through parameters. Then functions in C++. Different elements of a C++ functions are function prototype. That is the first property of a function. For every function, we have to define a function prototype, which includes the function name, its return type, and types of its parameters. Usually, we are writing function prototypes at the beginning of every C++ program. Function prototype says the compiler that we are going to use a function of this kind in this program. So during the prototype definition, we must mention the name of function, its return type, its type of parameters. Then second is function declaration. After the prototype, we should define the body of function somewhere in the program. It may be defined before the main program or after the main program. It includes the function name, its return type, and types and names of its parameters. It is something different from the function prototype. In function prototype, we do not need to mention the parameter names. Only types are required. But in function declaration, variable names or parameter names must be included. That is the difference between function prototype and function declaration. Then function definition. It comes just below the function declaration. Function declaration starts with the function heading, in which we are mentioning the name of function, return type, and types and names of parameters. Then just below that function heading, we should write the function definition, which contains the actual duty of that function and statements. All these are included between curly brackets. Then function call. This is actually the invocation of function from somewhere in the program. We can call a function from anywhere in a program. A function can be called from main, a function can be called from another function, a function can be called from that function itself, which is called a recursive function. So from anywhere we can call a function. During a function call, we must mention the function name and the names of passing values, names of actual parameters. The passing values are called actual parameters. These are used to exchange the values between function calls. The number of actual parameters and the number of parameters mentioned in the function declaration must be same. Also, the data type must be the same. So how to define a function prototype? The syntax is return type, function name, within brackets, type of parameter 1, comma, type of parameter 2, comma, etc. etc. The number of parameters is unlimited. We may use any number of parameters in a function, and if there is no parameters, only brackets are required. And finally put a semicolon. This is an example, int area of circle within brackets int. This means this function returns an integer value and it receives an integer value during function call. Similarly, the second example, it returns the float because it is the area of triangle which receives three sides of the triangle, and all these three values are of data type integer. So return type is float. That means within the function body we are calculating the area of triangle using these three integer sides, and we are returning a float value from this function. So exchange information are integers and float. Next is function declaration and definition. Its syntax is return type, function name, and type 1 space parameter 1, type 2 space parameter 2, comma, etc. And immediately after the function heading, we must write the body of function within curly brackets. So this is the body of function. So here is a simple example, int area of circle int r. See the difference here, variable name is mentioned as formal parameter. Here from the name of the function it is very clear that this function is used to find the area of a circle with radius r as parameter. In the next example, area of triangle, that means this function is defined to find the area of triangle using the received three sides A, B and C. So the body of function should used to find the area of a triangle. And finally this function should return a float value which is the area of triangle. So these are the two examples for a function declaration and function definition. The next is function call. How to call a function? As I mentioned earlier, we can call a function from anywhere in the program. The syntax is function name, within brackets we should mention the actual values to be exchanged during function call. Here parameter 1, comma, parameter 2, comma, etc. etc. Any number of parameters can be forwarded to the function. Example, area equal to area of circle 5. Here area of circle is the previously defined function name, and within brackets we are giving a 5 which is the actual parameter. That parameter will be passed into the function area of circle, and the calculated area will be returned and substituted at this function call. That value will be stored into the variable area here. Another example, again area equal to area of triangle ABC. Here three values A, B and C are transferred to the function area of triangle, and within that function triangle area is evaluated and returned to this function name. So the returned value will be substituted at this position. Therefore, that substituted area of triangle will be stored into variable area. Every function call is a substitution. If a function returns a value, that returned value will be substituted at the function call. Here area of triangle will be substituted. Here area of circle will be executed. So that area will be transferred to the variable area. Here also that substituted area of triangle will be stored into variable area. This is the kind of function call and function execution. The number of parameters during function call, that is actual parameters, and the number of parameters in the function declaration, which is called the formal parameter, must be same. Next is parameter with the default values. C++ function can send and receive any number of parameters. They can assign default value to formal parameters. Actually, formal parameters are the variables declared in the function heading during function definition. If a value not sent by the function call, default value will be assigned to the formal parameter. This is actually what is happening here. If we are not sending a value to a formal parameter, its default value will be assigned to that formal parameter. So that default value must be mentioned by the programmer during function definition. A function can be called with a different number of actual parameters by using this concept. The same function can be called with a different number of parameters. Sometimes we may call the function using a single parameter. Sometimes we can use two parameters for function call. And similarly, we can change the number of parameters during function call. That is the advantage of parameter definition with default values. Here is an example for parameter with default values. See this function int sum. Within brackets, we are defining int x, int y, int z equal to 0, int w equal to 0. These are the four parameters. We have not given any default value to x and y, but there are default values for variable z and w. The default values are zeros. That's why we are defining parameter int z equal to 0, int w equal to 0. So in this function, two formal parameters are without default values. That means at least two values must be passed on to this function. Body of the function is only one return statement, return x plus y plus z plus w. Then coming to the main program, the first statement in the main program is cout sum 20,5. Cout sum 20,5. What will happen? The 20 and 5 are transferred to the function sum. So these values are assigned to x and y. So x gets a value 20, y gets a value 5. The z is not getting any value from the function call, so its default value 0 will be considered. Similarly for w, there is no value from function call to w, but the default value of 0 is assigned to variable w. And finally, the calculation is going on x plus y plus z plus w. That will be returned to the function call. So 25 will be substituted during this function call. So that will be printed. Cout 25. Coming to the next statement, cout sum 20,5, 10. Three values are transferred to the function. So first value goes to x, second value goes to y, and the third value goes to z. So initial value, default parameter value will not be considered. Instead, 10 will be assigned to z. But we are not sending any value to w, so default value of w will be assigned as 0. And finally, we will calculate the result in x plus y plus z, 20 plus 5 plus 10, and plus w equal to 0. So we will get the answer 35 here, 35 in the function call. And coming to the third statement, we are passing 4 parameters to the function. That means x, y, z, w, all these variables gets value during the function call. There is no default value for any variables in this case. So all these numbers will be added and returned to the main program. So 20 plus 5, 25, 35, 40, 60 will be printed at this location and return 0. So this is a simple example for parameter passing with the default values. Now function name overloading. In C, function names must be unique within a program. 2 function definitions with the same name makes a syntax error. That's in the case of C language. All of you are aware about C programming and functions in C programming. In C, we cannot define a duplicate function name. If a duplicate function name is found by the compiler, it shows a syntax error. The function name must be unique. But in C++, same function name can be used for member functions in different classes because the scope is limited inside the class. So we are going to learn about classes. In such a case, we can define more than one classes in a program. In each class, we can define the same functions for different purposes. That means a same function name can be used in different classes because in each class the scope of a variable is limited inside that class. So we can define same function names in different classes. And C++ allows same function name for different functions in the same scope. That means we can define same function name within a block of statements. So duplicate function names are permitted in same block. That is another feature of C++. But we have to listen to some guidelines. The use of same function name for different functions with a different number or type of arguments, type of parameters is called function name overloading. That is, the way of writing a function name more than once in a program is called function overloading. So when function name overloading is possible in C++, only when we are using different number of parameters or different types of parameters are included in the function heading. That is the criteria for function name overloading. So function name overloading means writing same function with different parameters or with different types of parameters. The compiler will distinguish among overloaded functions by looking into the parameters. So the functions are same, function names are same, but the compiler can distinguish these functions by using the type of parameters or number of parameters. Then this is an example for function overloading. Here the function name is add. These two functions can be defined in a single program. Even if the function names are similar, this can be allowed in a C++ program because in the first function add there are only 2 parameters, but in the second function there are 3 parameters. So if we are passing 2 parameters to add function, first function will be called, and if we are sending 3 values to the function add, the second function will be called by the compiler. So compiler can distinguish these functions by counting the number of parameters. The return value is not taken into consideration when distinguishing overloaded function names. The function name must differ in either the type of parameters or in number of parameters. Here, return value cannot be used to distinguish overloaded functions. For example, this is int add int x int y. Two parameters, function name is add. The second case, float add int x int y. Here also there are two parameters. In both functions, two parameters are there. The data types are same, but the return type are different. This is not allowed in C++ program. That means return value data type is not considered for distinguishing overloaded function names. This is an example. Here a min function is used to find the smallest value. Int min, index int y, two parameters are there. The only one statement is return. A conditional statement is used here. X greater than y, then return x. X greater than less than y, less than or equal to y, then return y. That is the meaning of this conditional statement. If x is greater than y, it will return x. So coming to the double min, second function. This is a function overloading with the return type is different. Within brackets, double x, double y. Parameter data types are different. So this function overloading is permitted. Here also a return statement is used to return the minimum value. Void main program, cout min 2030. So in this case the first function is called with the two parameters 20 and 30 because 20 and 30 are integers. In the second case, cout min double 20 double 30. This is typecasting. I think you have studied this typecasting earlier. If we are not applying this kind of typecasting, this 20 and 30, 20.0 and 30.0 will be transferred to the first function, because in this case 20 will be automatically translated to integer and 30 also translated to integer, and the first function is called. To avoid such a function call, we must translate the data using typecasting. That is, we have shown in the second cout statement. Cout min double 20.0. That means 20 will be considered as double. 30 is also considered as double. So the second min function will be called. If we are not doing this kind of typecasting, an ambiguity error may occur. Object-oriented programming with functions. The main characteristics of a quality software are code maintainability, reusability, understandability, and independence. These are the main characteristics of a quality software. When we are doing software projects, all these points are to be considered. The concept of code understandability and independence should be supported by more specific technical criteria that are easier to recognize and use. Some technical criteria are needed to recognize and use. So the concept of understandability and independence can be implemented in a program. So these technical criteria are cohesion, coupling, encapsulation, and information hiding. By using these technical criteria, a project or a large program can be very user friendly, and we can maintain that program in an easier manner, and also we can reuse that program for another purposes, and everybody can understand these programs by using these techniques. So these are the 4 technical criteria for large programs to quality software. First one is cohesion. Cohesion describes the relatedness of the steps that the programmer writes into the same segment of code. That is a function. So the statements, related statements are combined into function. When a function has good cohesion or high cohesion, it performs one task over one computational object or data structure. When a cohesion is poor, that means weak cohesion, the function performs several tasks over one object or several tasks over several objects. A cohesion means a related set of statements should be grouped into a single function. If it follows a poor cohesion, the function performs several tasks. That means a group of tasks can be combined into a function. That is not understandable to others. So a high cohesion program is preferred in software engineering. High cohesion functions are easy to name. For example, insert item, find account. That means the first function is very clear in the function heading itself. Insert item. This function is used to insert an item. Only the statements used to insert item are present in this function. The second is find account. Only the statements used to find an account is included in this function. So very clear function name and a very clear set of statements are used in high cohesion functions. For example, the another is a low cohesion function. One has to use several verbs or nouns because this function is used to do more than one task at a time. Here is an example, find or insert item. So the above two functions are combined into a single function. So to find or insert an item, the same function is called. So this is a low cohesion function. It is advisable to write high cohesion functions to better understandability of the source code. Next is coupling. Coupling is also a feature of functions. It is useful in describing the flow of data values between function calls. Coupling describes the flow of data values between function calls. We have two kinds of coupling. One is implicit coupling. So functions communicating through global variables are following implicit coupling. When we are defining more than one functions in a program, we should call a function from one point and that function will be executed. So in that case, we can exchange values through function call. By using global variables, there is no need to transfer values in between function call because global variables are available in every functions. So implicit coupling means using global variables. It is not recommended in programming because it reduces the understandability and reusability. It is not recommended. Then explicit coupling, a function communicating through parameter. It is advisable. This is the better programming practice we have to follow in object-oriented programming. Explicit coupling. So this is actually we have explained earlier. Through formal and actual parameters, we can couple two functions explicitly. The next is data encapsulation. Data encapsulation is defined as wrapping up of data and information under a single unit. This is a kind of binding data and information. Data and functions can be binded into a single unit. In object-oriented programming, encapsulation is defined as binding together the data and the functions that manipulates them. This is the concept of encapsulation in object-oriented programming. For example, a company has various departments, for example, finance department, sales departments, etc. So, finance department has its own staff members, its own file system, its own secret data, its own kind of operations. So, all these operations are limited to the finance department. Similarly, sales department has some other kind of actions, some other kind of data. So these are confined to that sales department. we are not interchanging their actions or their data between the departments. So encapsulation is implemented in C++ by using class and access specifiers. We are going to learn about classes, and a class is used to implement encapsulation. This is a simple picture on encapsulation. We can use a class for encapsulation which contains methods and variables. So it is enclosed in a capsule as two parts. One part contains methods, the other part contains variables. Jointly it is called a class. We are going to learn about the classes. It improves to data security and simplify the maintenance of the source code. So encapsulation is used to improve the data security in a program. Then information hiding. Encapsulation leads to data abstraction and data hide. Abstraction means displaying only essential information and hiding the details. So only essential informations are available to others. For a simple kind of understanding, programmer need to know only the syntax of library functions, not the content of it. Every programmer is using library functions for C and C++ programs. This library function heading and function syntax is necessary to aware by the programmer. The programmer need not know any content of that library functions. This is a kind of abstraction. In C++, classes are used for information hiding. Programmer need to know the name of class and its functions, not the contents of the class. When we are defining classes, the programmer does not need to the body of class. He needs only the variables and functions of that class. From this video, you could understand the usage of functions, how to define a function, how to call a function, how to define function prototypes, how to define parameters and how parameters are exchanged between functions, and function overloading, then the advantages of functions such as cohesion, coupling and data encapsulation and data hiding. Thank you.